So? Ah, yeah, okay.
Problems, I'm in the first row.
Pardon? Sorry?
Hello everyone, I would like to welcome Christian Kaufmann, who's going to present how Akamai deliver your packets, the insight.
Hi. I guess for some reasons we actually lost some people, like 90% of the whole audience or so.
It was too long break.
2 more? 3? Please come in. It's for free. Still not exactly what I expected, but anyway. Then it looks more a little bit like a family gathering by now. Oh. I see more people coming. It's getting better. Okay, let's give them a chance and actually start with the usual questionnaire. I do that normally before instead of afterwards. So who of you is actually using a Microsoft laptop and downloading Microsoft patches once in a while? 2, 3. Oh, I see we have a Mac user group here. So who is using a Mac and downloading Mac patches? 1. The other ones are not using computers. 3. Good. Are you sure you're in the right room? Good. Let's make it a little bit easier. Who is actually using eBay or Facebook? Committed. Oh, also just 3 or 4. Good. Well, coming to the point, whenever you are actually using these services, so you're downloading a Microsoft patch, or you're actually buying something in the Apple Store, or you're downloading an Apple patch, or the pictures on eBay or Facebook, then I'm not sure if you were aware of it, but actually most of them, or nearly none of them, coming from the company itself, or from the servers of the company itself. They're actually coming from CDNs. And this is what I'm talking about today. Akamai is one of these CDNs. We have another one, Limelight, here in the first row. And I go through some generic examples, basically how CDNs work. And the rest, or most of them, are then Akamai specific, so that you actually see and have an idea from where your content is coming. Good. Going one step back, and actually see what the RFCs say about a content delivery network. They actually have a definition of it. So a content delivery network or content distribution network is a type of network in which the content network elements are arranged for more effective delivery of content to clients. Right. Any other question to that? For all the people who are as confused as me after reading it, let's try it in English. So end of the day, a CDN is like an overlay network. So even if the CDNs, and that is probably more true like for the Akamai type CDNs, even if they are using routers, BGP, network equipment, they are actually using BGP, but they are working relatively different in comparison to a normal ISP or provider. CDN tries to deliver the content as close as possible to the end user. So that end users, eyeballs, that is basically people like you, I, sitting at home, looking at the content we described before. And what a CDN tries is to bring it as close as possible to you, so that from a latency and throughput perspective, you get the best possible experience. So instead of getting it basically like in the Warsaw example, so instead of getting the content downloaded from the US so that it goes through Europe, probably over the ocean, and in a worst case even through the whole US, we try to bring it closer to you. So in an ideal case, that means we put a copy of the content you are interested in, like to the Plix. I guess that is probably as close as it gets. CDNs, of course, as they have the content, have to store and put the content somewhere, so we have servers. In our case, actually a lot of them, And these servers are separated by type. So depending on the network protocol we want to deliver, we might have different servers. Then we stack them all together in a rack, build fancy clusters out of it, and then we deliver the traffic from there. The servers, that's at least true for our case, are normally not shared between the protocols. So a Flash server does Flash, a HTTP server does HTTP. So they are basically optimized for the type of content they are delivering. Now the big difference between the CDNs. So there are CDNs which are network owned or which look like a network to the outside. Good example is like Level 3, Limelight, the part of AT&T. So they basically put these servers in their own network, in their own AS, and then they deliver the content from there. To the outside, there's actually not a big difference. If you peer with them, or I guess in case of Level 3, you can buy transit from them, you basically get it via normal BGP connection, and everything looks like a normal network, nothing fancy on your side. And all the fancy stuff is basically done on the CDN side. There's another kind of CDNs. These are the ones like we, or Panther Express, like CD Networks Now, and some others, which have a little bit of different strategy. So we are still basically peering and having normal BGP sessions to the different eyeball networks, but we also putting servers in the network. That's what we call on-net. So we basically put, if you're a bigger eyeball provider and you have, I don't know, a couple of 100,000, 10,000 of end users or more, we start to put servers in your network, if you like that, of course. And then these servers will deliver your eyeballs. So it's the same content like normal, but besides that you don't get them via transit or peering, you don't have to backhaul them. You actually can decide where you deploy them. And we can even build multiple clusters. And then you basically don't have any backbone or backhauling costs, and the speed is even faster than in case of a peering. If that is the case, or if you actually look at traffic like what you get from Akamai, then you not just can look at the net flow stats. So even if you have figured out our IS number, 2940, and you look into your net flow, then you actually just see the peering traffic. You would not see the on-net traffic, which might come to you from other networks, because they will basically have the IP addresses and the AS numbers of that particular network. So if you really want to know how much Akamai traffic you have, you gotta send me an email. And then I look in our fancy tools, and then we actually can compare what your ratio is from other networks and what the ratio is versus peering or transit, where you then actually can see the AS number. One real number marketing slide, that you get a rough idea what we are talking about. So right now we have 85,000 servers, all spread over the world. I think on every continent besides Antarctica. We are in 1,700 POPs, which is kind of data center POPs / cities. We are in, and that is one of the big differentiators, in 950 networks. So we have 950 partner networks where we put the servers directly in their network. The rest, usual things, 660 cities, 72 countries, and a little bit over 5 terabits of traffic peak. So, is that me? Good. So, let's have a look how the different CDNs actually work. So, when you request content from a CDN, then there are two kind of possibilities. One is, if you get it from like a non-network owned, like an Akamai kind of CDN, then this is actually done via DNS. When we go through that in a minute, and I show you where we actually make the decision where the closest cluster is for you and how the customers actually point CNAMEs at our clusters. If you get content via a network-owned CDN, like Limelight, for example, then they work, first of all, with Anycast. So if I'm not mistaken, then they basically announce all the same prefixes from their cluster in the different cities, and then you get via BGP routing automatically to the closest one. There is a big program, and I come to that, we call it mapping. Mapping is like a big software tool on our side where we try to figure out where actually you are sitting and which of our clusters would be the best one for you from a performance perspective. Apparently, if we find a way to improve the mapping, then actually, of course, that makes the CDN better. So let's see how we actually do this mapping and which kind of feature we have here. So Symantec, for example, is one of our customers. So if you're actually sitting either in different networks, or you can use different looking classes or whatever, and you look at host Symantec.com, then depending on where you are, you get a different IP address back. So like in this example, the New York one above obviously has different IP addresses than the one in Boston, and you then get redirected automatically to the closest cluster in hopefully your city or close enough. So whenever you're actually wondering if you are looking at Akamai's traffic, then putting a host or a DNS lookup into it, then you actually can see that a CNAME is pointing for the web address, or pictures.apple, whatever, is then pointing at something cryptic, and then akamai.net at the end. And then you actually know that this part of the content you are downloading right now comes from an Akamai server. So that is probably the most complicated slide, with a lot of movement from the marketing department. So let's have a look. If you sit at home and you're the end user and you type in a URL, then what normally happens is your browser looks into the cache if you already looked at it, to basically figure out the IP address. If that wasn't the case, then you might ask your operating system. The operating system, if it also doesn't have an idea, would ask the local name server, your resolver. You normally get via PHTTP or any protocol from the provider, or you have hard configured. And then this resolver starts to look up the IP address of the name you typed in on your behalf. So what he's basically doing in the background, which is kind of hidden from you, is, of course, first of all, he goes to top level and roots and tries to figure out the name server of the particular customer, like Symantec.com. After you have figured out the name server, and you can ask the name server, and you ask him, like for this example before, www.symantec.com, then what Symantec does is they're not giving you back an IP address like in a normal static scenario. They are giving you back this fancy magic Akamai version, the cryptic versions, which is a mix between customer and service ID mixed together in one number. And then your name server starts all over again and looks basically for Akamai, if it's not in the cache already. You get the high-level name servers back. And the high-level name servers then are telling you what we call the low-level name servers, just to make it complicated. And this is actually, step number 12 is actually the magic step, where we're giving you the IP address back. Not just one from one cluster, where we actually give you back the IP address from the cluster which is closest to you. So with various methods, which I will show a little bit later, we basically figured out a big table where we have, for the different prefixes and from the different resolver, an idea which cluster is the closest and best for you. So we give these name servers then basically exactly this IP address, which is the best one for you, and you get that one back, of course. And then the rest of the steps is basically the normal DNS resolution, where you get suddenly then an IP address back from your resolver. So the whole thing actually consists of two important steps. One is between 6 and 7 on the left side, where actually the owner of a domain, like Apple, Microsoft, whoever, points to us. And then the rest is basically number 12, where we then give you back one specific IP address, depending on where you are located. This is of course just for the case that you have not cached anything at all. If you actually have cached the name server of the customer before, or if you actually have cached, the high-level name servers of Akamai because you were on, I don't know, Microsoft first and then you went to the Facebook part. So if the high-level name server is already cached in these, then of course you have less steps in between. So this is basically a complete cold lookup, if you like. So, as mentioned before, we try to find the closest cluster for you. But actually, how are we doing this? Well, what are we doing is we mainly look at the latency. Because end of the day, latency is one of the most important points which has an influence on the speed. So we try to figure out a server which is close to you from a geographic region. Because end of the day, the whole speed of light thing still counts. And as far as that is not solved, we gotta find something which is close to you from a geographic region. This said, we also look for throughput. So we actually try to see if we have enough bandwidth to you, or if that particular cluster where we want to send you is either not overloaded, has enough CPU load, enough hard disk space, no packet loss, if the network utilization is good enough. So if you actually talk about cities like Amsterdam, for example, where we have a lot of different clusters. So even if you're sitting in Amsterdam and you have probably 20 different clusters and candidates where you could go, we then, where it doesn't really make a big difference from a latency perspective, try to send you to one which either already has that content cached, or at least is not overloaded. There's no point sending you to a cluster which is closer and then the cluster can't deliver in time. All these different methods and tools will then generate basically what we call the mapping system, and then end of the day they generate these big tables where we basically say, if you're coming from that kind of IP, then this is the closest cluster for you, please go left, please go right. So, now we're coming to the fancy moving slides. So, and I guess that is actually more or less true for all CDNs, how they work. So we have the different things, different services we actually can deliver. So the first one is you are the end user on the right side and you try to get to one random website and you actually go back to the origin. That is basically the server of the company who is owning the content. Because don't forget it, we are just delivering the content. We are not the owner of Microsoft, Apple, whatever, Facebook. The content belongs to the company. We are just helping them to spread it and deliver it. So you're going back to this origin, you get an index.html, that is the first or most old style version of a CDN. And then, because the index.html is normally a relatively small page, we could do all the heavy lifting, which is basically pictures, videos, embedded objects, and deliver them from the closest cluster. Of course, you can go a step further and say, well, if I already send every picture and every embedded object, please deliver the index.html of the first page too. Okay, let's have a look at this. Same story, you request a web page comes from the cluster itself, doesn't go back to the origin. And then all the pictures and all the embedded objects coming afterwards. Well, this said, so far all the content was static. So, like a prepared website, not a lot of changes. So a lot of people actually come and say, well, this is all just fine for static content, but it doesn't work with dynamic objects. Well, that is actually not exactly true. Depending on which kind of dynamic content we talk, there are actually possibilities like with Java Edge or with parsing of websites and with database